దీంతో సెకండ్ అండి. నేను కింద నుంచే చెప్తానండి. అవునా? ఓకే ఓకే. స్టార్ట్ చేయొచ్చా? ఓకే, స్టార్ట్ చేసేయాలి సార్. చేసి ఓకే, గుడ్ ఆఫ్టర్నూన్. ఓకే, గుడ్. At least you started with energy. Okay. In the last, I will see how much energy will keep up. Okay. I think the topic is, it's like again electric vehicle application only, mostly related to battery. How to, it means increase the life or something. Before that, సార్ నేను క్లోజ్ చేస్తానా? ఇటు మీరే చేశారు కదా. ఓకే. Okay. Listen. Try to వచ్చాను, ముందుకు వచ్చాను, పర్లేదు, ఇంకెవరు రారులేండి. ఈ రెండు వదిలేసుకొని రండి, ముందుకు వచ్చాను. ఫస్ట్ 2 సీట్లు వదిలేదు, అవి 2 హాట్ సీట్స్ అనుకుంటారా అక్కడ. ఓకే, లాస్ట్ బెంచ్, ఈ ముందుకు వచ్చాను, లాస్ట్ బెంచ్. ఓకే, గుడ్. ఇంక ఇటు వినండి. The main contents for this presentation are: first, introduction to electric vehicles. It's like just motivation, why and how. Then we'll see the classification of electric vehicles, and then we will try to understand. Here. లాస్ట్ బెంచ్ ముందుకు వచ్చాను, మీకు వచ్చాను, పర్లేదు, నేనేం చేయను, వచ్చాను, ముందుకు వచ్చాను. ఇవి చిన్న క్లాస్, మాకు అక్కడ 160 స్ట్రెంత్ ఉంటుంది, ఒకే క్లాస్. మా మా ఎలక్ట్రికల్ 160 స్ట్రెంత్, ఒకే క్లాస్ నడుస్తుంది. ఇలా ఉంటారు స్టూడెంట్స్. ఓకే, ఇక్కడ ఓకే, ఇట్స్ నాట్ ఏ ప్రాబ్లం. ఓకే, by the end of this second, we will try to understand why battery is important. Then we will see how our battery how to improve the life of battery. Just a small research topic I want to mention. This is just motivation why electric vehicles, if you see, it's actually the crude oil imports are around 103 billion. The problem is the money. We are giving so much money to other countries. That is the problem. In addition, it means our Indian currency is going away. It means in the form of imports. That is the one problem. The other problem is something like dependency. If you are depending on some other, definitely you have to always depend on them. Suppose if they tell I don't want to give, then what you will do? One fine day they will tell I can't give. Something happened, like I think I was in Singapore at that time. There is small disturbance between Malaysia and Singapore, and Singapore depends on for water on Malaysia. They told if you talk more, I will not give water. They are telling. Then what they will do? Anything may happen, yes, but they took it as a challenge, and now they have the waste. From the waste they are producing good water. It means they are recycling the water. Now they are best in water technology. Now Singapore, it means like we have to become self-sustained. Okay, that's the main. it means the oil price is coming down, still we are depending on some other country because we don't have reserves, yes, sufficient reserves. So that's that is the first and foremost. In addition to that, the one more important is pollution. Yes, okay. If you see here, this is 6 by 10 most polluted cities in the world are in India only. And also we can just, one more important is why electric vehicle if you talk, its efficiency also. The first one, if you see this is electric vehicle one, this is conventional, the present vehicles, whatever is running on petrol, diesel and everything. Suppose if you see this, they are taking this crude oil. They are taking this crude oil, they are refining and they are giving to petrol pumps. And from there you are putting that petrol into the vehicle and you are burning on the streets. Yes. Here for refining it is 82% efficiency, transmission 98% efficiency. The overall efficiency of this petrochemical is this process is 80%. And once you put petrol into this, then the efficiency is 16%. 16%. So the overall efficiency of the whole system has become 13% here. Now if you come to electric vehicle, there you are producing power. Here the worst case possible, that is from the coal, thermal power plants we have taken. Maybe we can replace this with some renewables later. Okay. Now this is thermal. Now you are converting from this coal, gas or whatever it is, and you are getting the electricity. Here the efficiency is 31%. From here, from meter to here, the efficiency in electric vehicle is 76%. The overall efficiency is 23% here. It means it's almost 13% here, 23% here. So the efficiency is improving. Yes. So we can save, I think someone told like, if you save 1 unit of your electricity, it's equivalent to you are saving 3 to 4 units from coal, which is equivalent, which can produce 1 unit of your electricity, something like this. Here also it's 50% more, around 70 to 80% improvement. Yes, efficiency. In addition, maybe this process can be replaced with renewables so that your pollution can be reduced. That's one more important. See, this one try to understand so that you can correlate your vehicles, electric vehicle. This is IC engine based vehicle efficiency map. This is electric vehicle efficiency map. In this, see the efficiency is looking like this is efficiency, this y-axis this side, this one is torque, this is speed, this is speed. Suppose we compare for a particular case. If you take for a particular case we can understand. Suppose we assume that 3000 rpm and 80 Newton meter is the requirement for us. 3000 rpm, 80 Newton meter is the requirement. Now the efficiency here is around 0.29. It means 29% is the efficiency. Efficiency in normal IC engine based normal vehicles. Okay, the same thing I told 3000 rpm and 80 Newton meter. 3000 rpm and 80 Newton meter. Here the efficiency is 91%. Here the efficiency is 91%. One more thing Why do you think when vehicles which are having gears are having good mileage as compared to scooters? Can someone? That's the one. Automatic gear. Yes, that statement wise, that's right. Automatic efficiency, automatic gear changing is good efficiency, but in scooters, there is a gear change or not, that is different issue. Uh, but normally, all the scooty, suppose if you take Honda Activa, the mileage is 25, 30, 30, 40, you can assume. 35. Now if you take the 100cc Splendor, 60. Why? मतलब दोनों में इतना अंतर क्यों? हाँ? Why do you think? हाँ? मतलब gear डाल रहे, you are putting gears ना? What are you really doing there? By increasing gear, first, second, third, fourth. क्या कर रहे हैं exactly? What are you doing? हाँ? Acceleration. No, not acceleration. Okay, first understand what is first gear is doing. First gear is very slow. If you need high torque, low speed. Yes, high torque, low speed. If you are in fourth gear, high speed, low torque. Yes, suppose up is there. If you go in fifth gear, will you able to go? No, you have to come for first gear. Yes, okay. Gear means what it is doing. Huh? Gear means gear only. Gear, morning we have seen that wind turbine, gear changing, speed changing. Something, yes? Yes, okay. If you go in fourth gear, speed will be increased. Then power, if power is constant, if speed increases, torque, what will happen? Decreases. Yes, power equal to torque into speed. Yes, okay. Now, if you see the efficiency map, you can understand this. Suppose if my torque is 20 Newton meter here, if my torque is 80 Newton meter here, then what is the efficiency here? If 20 Newton meter, 16%. Huh? If this is 80 Newton meter, 28%. 16 and 28. How much difference? Around more than 50% difference, 80% difference, 16 to 28. Suppose if you operate at this torque, this much is efficiency. If you operate at this much torque, this much is efficiency. Okay. It means, suppose if you operate at higher torques, you will have good efficiency. Yes? If you operate at higher torques, you will have good efficiency. Okay. Now, you require at different speeds. Suppose you need to operate at lower speeds. Now put the gearbox. Put the gearbox and increase the speed. Increase the speed. Okay. Put the gearbox and increase the speed. You try to push. You try to, suppose in scooty, suppose if you don't have gear, okay, depends upon speed, it will operate in the whole range. The whole range. Suppose if you have gear mechanism, you always try to put your operation above, in the top. You want to put the operation in the top always. Okay, you are changing the gears manually and you are trying to keep in the above range always. Okay, if you are not using that, if you are using simple scooty, this will operate at whatever may be complete range, it will operate, the efficiency will be changed. Okay, even if you see like economy will be there 30 to 60, 40 to 60. If you operate your vehicle you will get good efficiency. Okay. Now that's why if you operate at lower speeds, your efficiency will be reduced. Yes, if you operate at lower speeds, your first gear and second gear, if you go, your motor will become heated up also. Your engine also will be heated up mostly. It means there will be more losses. There will be more losses. Okay, so your petrol consumption is same. You will have more losses, and so petrol will burn easily. But if you are using gears, you are shifting on your own. You are shifting on. You try to improve the efficiency always by changing the gears. Okay. Now, in the same, suppose if I use electric motor, not IC engine based, but electric motor. Suppose the same case, if I change my operation of torque from 20 to 80, something like this. How much is the efficiency it's changing? 89% to 95%. Is there any change? Hardly no change. Sorry, hardly any change. Okay, there is no change at all. 89 to 95%. It's 6%. Here the change is 0.14 to 0.32. It's more than double change. Here only 3%, 4% change in the efficiency. It means that's why you always, okay, operate in certain zone such that your efficiency will be improved. That's when maybe I think you have some idea of cars or not, I don't know. Hybrid cars. What? Along with normal. Yes. Now I think our Brezza hybrid, Grand Vitara hybrid, this come. They are claiming now around 25, I think. If it's our what is per liter mileage or whatever it is. If we normally take Swift and all these things, they are around 13 or 14. 13 or 14. Yes, normal Swift, normal, if you run only an IC engine, the 13 or 14 is mileage. But if you run on hybrid, the combination of this petrol plus your electric vehicle, the mileage you are getting is 25 or 24, they are telling. Why do you think? Suppose if you are you want to operate here, yes, then this much is the loss is very high here. At that time you try to operate using this. You try to operate using electric motor. From the battery you try to operate for increasing the efficiency. When you are in traffic, when you are operating at low speeds, battery power will be used and it will be consumed. Suppose when you are in highway running very good, then if you are applying some brakes or sometimes by using regenerative braking, you try to save some of the power and send to your batteries. Yes, you are saving some power. First thing, you are storing some power, you are utilizing some power, and also utilizing the same power when running at a very low speeds. Okay, that is saving. That's why your mileage overall is improving there. If you go for hybrid means you don't need to in the hybrid you don't have any option to charge your vehicle. You have battery inside, but you cannot be charged. It is not plug-in. You have to it will be charged internally by using regenerative brake. Maybe we will see that. Why electric vehicles? I'm telling, if traction effort or otherwise if the wheels are running by an electric motor, that is called an electric vehicle. The main classification of electric vehicles are electric vehicles, hybrid electric vehicle. Hybrid means electric plus IC engine based, and also fuel cell based electric vehicle. This is simple electric vehicle. This is an electric motor running from an electrical source. Electrical source means this may be battery and power electron DC to AC converter, and you are running an electric motor to run a vehicle. Now, how you are getting that energy into a battery, that is different story. How you are getting energy into a battery is a different story. Maybe you use petrol to generate power, or otherwise you are charging from the home, or whatever it may be. But if your motor is running by an electrical source or electrical power, that is called an electric vehicle. First thing, electric vehicle means electric motor is there. Now, this is hybrid. Hybrid means here you are using engine, petrol is there, you are using fuel tank, and there is a generator connected, and we are converting this here from fuel to mechanical to electrical, and you are charging the battery. This is normally they are doing in this hybrid vehicles, like whatever I am telling, Grand Vitara and all these things, mild and hybrid. And from this battery, this electric vehicle. Here the thing is, this is pure an electric vehicle because this was run by electrical motor only. And these two sources are connected in series. So this is called series hybrid. Now this battery, in the previous case, it was not connected outside. To charge this battery, the only way is by running this IC engine. Maybe you keep it idle, this one, and you can charge, or otherwise maybe while running, if some leftover power is there, maybe that can be used to charge, or anything you can do it. But in this next case, this battery you are charging from the external source. This is called plug-in hybrid. Now you should understand the difference between hybrid and plug-in hybrid. Plug-in hybrid means the battery you can charge it. That is called PHEV. The terminology. If you see PHEV, plug-in hybrid. And hybrid means maybe you don't have access to this battery. This will be charged by the IC engine only. Okay. If you see normal our electric vehicles, maybe purely you don't have this. Pure electric vehicle, only you will have this time. Okay. Okay. One more thing, parallel hybrid. Now these two, if you see, in the previous case only electric motor is there, but here there are two motors here. This is mechanically, you can mechanical is there, here this is electric is there. Okay, both of them you can run using this electrical motor or mechanical also. In the previous case, this mechanical energy was converted into electrical energy and that was sent to a battery. But in this case, here the addition of power is through mechanical, not electrical. Previously, the addition of power is through electrical. This is electrical energy, this is electrical energy. But in this case, both of them are mechanical. This is parallel hybrid electric vehicle. Here the advantage is like simply you can use it like a simple petrol. You can use it. Suppose if you don't have battery based means to charge also, you can use this petrol base and you can go. This is series parallel. I think it's not. It's combination. So if you see here, this is plug-in. This is hybrid. In hybrid means here you don't have external plug to charge your battery. Here you have plug to charge. Okay. Normally, here in hybrid, maybe you can have IC based also. You can drive. Here you have only electric motors. Okay. But in plug-in electric vehicles, only it was run by electric motors. Okay. The other things are, one more important thing is this fuel cell based electric vehicles. This one is also it's going to be very good in the future. If maybe some of you can try doing some project in the fuel cells also, that's very important. And I think in not only that, in electric vehicles, maybe if I tell you, uh, normally in IITs the placements will be mostly software BTech people prefer. They prepare for artificial intelligence, machine learning, and all these things. But this is the first time, means even our electrical people, they will tell what is the use or why we are studying this. Like that they will tell. But first time this placement season they understood why they should study electrical, because the whole AI and ML they have studied, artificial intelligence, machine learning, they will never be idle. Normally the students will never be idle. In every break, in 2 months, either they will go for internship in the college, or normally in the any industry, or online they will learn some courses, they will do some certifications, something they will do. Normally in all the, means in breaks, normally they will not be idle. Even if they sit at home, they will do online some internship, some course they will do, NPTEL course, something. Normally even they don't prefer NPTEL, they prefer outside some certification courses they will prefer. But they have done, they are ready, they thought, oh, fourth year come, we have these many certifications, we learned Python, we learned this, that, they went. Now suddenly the software companies, they are not in a position to take. Now they are asking, have you done something on electric vehicle? Some Vola, they came, they offer 25 lakhs package. And the people who have done on really something on hardware or something learned electrical, they have taken that. Now electrical people have placed first as compared to others this year, first time. It means we never know what will happen. So read electrical, okay. In future, if you, the technology is changing, we never know, okay. Previously mechanical is very, all your vehicles are mechanical. Now they are so slowly shifting to electrical. Everything is electrical. If you see why you need, you are putting fuel and you are converting, here it is running, why can't you use this to run this? Again you are converting into electrical, and electrical motor you are using, because it is efficient. It means the things are like that. Now we are, each one person to everything is so matters, okay. Likewise our electrical is going to boom in electrical vehicles. Now you do whatever internship somewhere, or something, but apart from your all this preparing something for softwares, you try to do some good internships also and learn. Got? No? You do. Anyway, you will bother later. How to choose motor for an electric vehicle? This is normally if you go to our lab, they will tell, sir, this is 3.7 kilowatt machine, 1500 RPM, they will tell. It means that is rated. Yes, that is rated. But in electric vehicle, there is no such type of thing like rated or something. It has to operate throughout, from 0 to whatever speed, it should operate well and everything. Normally, something they have mentioned, either this is nominal or nominal power, okay, and it should be in a position to operate the throughout, okay. Normally, the motor you have to select in such a way, and the nameplate just give you the maximum power, but it should be in a position to operate everywhere, okay. And it should also generate torque over a wide speed range. In normally if you have IC engine base, Normally you will have gears. Even if you generate 1000 RPM, maybe by using gears you can get it 2000 RPM. If you want 500 RPM also, use reverse gear and get it 500 RPM. From 1000 RPM to 1000 RPM, 1000 to 500 or 2000, you can get it very easily with the help of gear shifts or gear. But in electric vehicles, you don't have gears. Now you should be in a position to generate the torque throughout 500 RPM to 2000 RPM complete. You have to get sufficient torque. You have to get sufficient torque. That's the main challenge in an electric vehicle. The motor should be in a position. Normally in IC engine, it's not the case. You generate at a particular speed, change the speed according to your gears. So this is little bit difficult. Okay, the motor should be selected in such a way. Normally all these are motors. Now I think DC motor I am mentioning, but it's obsolete. Nobody uses. In previously they used to have, even I think small toys also they are not using DC motor. They are not using anywhere nowadays mostly. Even in toys also you have 1.5 volts battery. Even small children they use small toys also. They are also using PMBL DC with inbuilt some motor control. That 1.5 volts battery if you give, it will run. Previously that used to be simple DC 1.5 volts if you give, it will run. It's like that. But nowadays people are not at all interested in all these things. It's like everything is PMDC, PMBL DC and everything. DC motors are now obsolete. And induction machines, yes, this is people are using everywhere induction machines because these are robust. These are squirrel cage. You don't need any maintenance type of thing. Okay, this is very good. But the problem is power factor. Yes, and permanent magnet machines. These are better than these induction machines because you don't need to supply any reactive power. But the issue is, these are costly. You need permanent magnets. You have to import from some other countries. That's very difficult. Yes, you are again depending on some other countries. One more thing is like there is some life for your permanent magnets also. Okay, sometimes they may demagnetize after a few years. Okay, that's the one more problem. This is very good. Switch reluctance machine based. These are, you don't have any winding in the rotor. You have simply some metal will be in the rotor, and if you don't have winding means the weight will be reduced. So this is now I think this is picking up. Switch reluctance machines, those are previously space applications. They used to have this switch reluctance machine, but now there are some good controllers, so they can use it for any of the even electric vehicle application also. Some of the companies, I think some Kerala, he want to use it for some two-wheeler. He has approached us for the drive. He want to prepare a drive for this switch reluctance machine as a consultancy. It means people are going for it. Now they are going for this switch reluctance machine drive. And synchronous reluctance machine, this is like normal our wound field synchronous machine. If you don't have that field supply, that is synchronous reluctance machine. It's normally they use for previously synchronous condensers. Yes, synchronous reluctance machines. But now they found to be very good in synchronous reluctance machines. Even I think now Tesla, previously they used to have these induction machines for electric vehicles. Now they are going for synchronous reluctance machine, and the combination of this, the rotor they have started with permanent magnet machines, and now they are doing with PMSYRM. Permanent magnet synchronous reluctance machines they are using in their now all the Tesla cars. That's now I think very they are telling it's very promising, very good. Okay, this PM synchronous reluctance machines. Now I think some of the DC motors I think not much use, but induction machines, this is very much. Once this power electronics came, previously if you take induction machine, if you give 415 volt supply to an induction machine, At what speed it will run? By removing some slip, it will run at a particular speed. Suppose if I give my 230 volts, will it run at according to the voltage or what? Have you seen in lab? Suppose I have 220 volts DC machine. If I give 110 volts, maybe it will run at half of the speed, around. Not exactly, but half of the speed, around. But if I do the same thing to an induction machine, here torque is proportional to V square in induction machine. Yes, induction machine torque speed characteristic, torque speed curve, if you see. Yes, okay. Like that, if you see those induction machines, the control is not so easy, not so easy. And if you want to operate at half of the speed or 1/4 of your speed, if you don't have power electronics, because you need variable voltage and variable frequency to control. To do that, you need a power electronics. Now it was mature technology. Now that's why all the industries, they are going for this induction machines, because you don't need any slip rings type of structure. Some of the induction machines they are using, this is Tesla Model 3 long range dual motor. This is older versions actually. If you see here, the battery rating is 74. This is one more Tesla motor. Tesla, they are using induction motor in this. And Mahindra, in this they are using induction machine. Now come to the PM machines. Now recently, almost all the vehicles, they are using permanent magnet machines. In this, the advantage I told, you don't have, the losses will be little less. You don't need to supply reactive power because permanent magnets are there. You don't require any reactive power, so it's very good. But it's rare earth material, so you have to import from other countries, and also costly. And also, sometimes it may be demagnetized. Yes. Some of this in Exxon EV, they are using permanent magnet machines. They are using, and this is battery rating is 40.5 kilowatt hour. Motor power is 106. And this also PMAC, Tata Tigor EV. They are also AC, permanent magnet. This is also PMAC in Tiago. It means previously induction machine, now comes to PM machine. Now PM also, it's PM synchronous machines. Now people are going for PM BLDC. This is also PMSM, again PMAC machines. Now comes to PM BLDC. In all two-wheelers, they go for PM BLDC. In all two-wheeler electric vehicles, mostly they use PM BLDC. The difference is not much, but here you will have the back EMF is, you will have their sinusoidal in PMAC. Here you will have trapezoidal type of thing. In this PM BLDC, ether, they are using this PMDC. And also Ether 450, they are using PMBLDC. Almost that too, they are going for hub type of motor construction. The motor, it means the stator is fixed, on that the rotor is moving, and that was connected to your shaft. Okay, that's called hub type of motors. This is all of them mostly PMBLDC only. All the two-wheelers. In addition, this one, in three-wheelers, they are going for PMBLDC. This time, maybe, have you ever seen this? यहाँ पे आ गए क्या? మన దగ్గర ఉండవు కదా ఇవి? ఉంటాయా? వచ్చాయా? ఓకే. అక్కడ చాలా నార్త్లో చాలా ఎక్కువ ఉంటాయి ఇవి, ఫుల్గా అవే ఉంటాయి. ఇది these are also working on PMBLDC. Here most of them, they are little less costly, they are easy. because they are using lead acid battery technology. They are little cheaper. Okay, most of the people first they will purchase it. After 2-3 years, the batteries will be gone. Again, they have to purchase new. These are all PMDC only, BLDC only, lead acid. There is nothing in this actually. Just purchase one. Someone will prepare this structure. Lead acid battery they will purchase, and from China you can get the BLDC with driver. You will get some motor. Just fix it, and you can prepare your own auto. That's very easy. Yes. Mechanical side they will do something. The electrical side they will purchase in bulk and they will fix it. But lead acid they are using, but if major companies come into this field, then they may replace this with lithium ion and the cost will little increase. These are EV chargers. I think EV chargers are two types. One is called off-board charging and on-board charging. In off-board charging means not on vehicle and outside on the ground. Then you will have big chargers. These are all called off-board chargers. They are on the ground. From there you can charge. Now you don't have any require space problem. You can have very big. Now even people are also not happy. Even in the metro cities, even they are getting problem with the space also for this. But theoretically, there is no space constraint for off-board chargers. This is normally high transfer of energy. These are fast chargers. They works on directly DC, and they transfer it very high fast rate, and the weight you need not have weight on EV, and you can have more. There will be communication between your even if you take our batteries mobile if you charge first 80% you will get it very quick charging. Yes, within half an hour you can charge it up to 80%. For next 20% it will take half an hour, 1 hour or something like this. Have you observed that? Yes. Then how it will know that 80% charged or something? How charger is there? Charger is there. You kept to your phone charging. First of all, battery should the charger should know this battery was charged 80%. Then it will start charging slowly. Okay, there should be some communication. Even if you are putting those USB or micro USB, other than your power, there will be some communication also to understand what is the battery voltage in your charger. Something like this. So here you require proper battery management system, because if you charge at the same higher rate, even throughout 100%, if you give constantly giving that much high power, your battery will explode. First of all, your charger should know what is the charge present, how much it was charged, and first it can charge it very quickly. Later, it has to reduce the charge rate. Okay, for that is called battery management system. So the battery management system here now you don't have any constraint. Now as you have very big what do you mean space. Now battery management system you don't have any space constraint. The other thing now, and also more complexities and higher cost you can do it, and BMS system less complex. And some of the chargers, if you take highway charging, maybe you can charge it in 15 to 30 minutes, and some of the commercial chargers in malls, that is 30 to 120 minutes, and some of the offices, this will take maybe in working days less power, this is 8 hours, and in homes it will take maybe more than 8 hours, I think, more than 8 hours. All these are different types of chargers off board, and some of the chargers that were manufactured, these are at Delta. This is 50 kilowatt charger. It can charge very quickly. Some of the off-board chargers, Schneider Electric, they have the charger. The This is the connector. The name is this one. What is it pronounced? I don't know. Chademo. This is, if you see, the power is 50 kilowatt. It's huge. It's huge. I think now people, I think in our college, I think some electric vehicle conclave was done in last, I think last month. Even there, some of the people, they are telling, I think one from Mahindra and another from some other company, they came, they are telling the charger should be in a position like petrol, how much time it will take. This also should take that much time to charge your vehicle. That's their actually plan they are telling, but I don't know when it will take, but they are planning for that. They are telling they are going increasing the power rating. That increasing the power rating is not sufficient. You should be make ready your BMS and battery also should be able to withstand. Yes. This is Tesla. This is 250 kilowatt. 1/4 megawatt it means. Some of the DC fast chargers, this is 350 kilowatt, will take 7 minutes. Even now people are not happy with this. They want to go further down to 2 minutes and 3 minutes, something like this. I don't know what they will do with the batteries. These are regarding off-board chargers. Now on-board chargers are, this is the charger which is sitting on your in your vehicle. This is on board, and here the constraint is space. If you have very high power, again always you have to carry with that, so it should have less weight, like your space applications also, everything. Even if you reduce one case, that matters a lot, because you need so much fuel to go. Yes, even even like here also, space is the problem and also weight is the problem. So that's why they are going for, in this onboard chargers, they are going with some of the technologies like silicon carbide, MOSFET based, some of the chargers they are going. There your size can be reduced. Okay, you can go with the switching frequency of around in kilohertz. Now they are start entering into megahertz range. Normally, these onboard chargers, they will, some of the companies, they will tell 7.5 kilowatt, but I don't know if I have single phase supply, what I will do with my 7.5 kilowatt. It will operate at 3.7 kilowatt only. Yes, in single phase supply, what is the plug pin rating? Accordingly, if you see, that is only 3.7 kilowatt. Suppose if you have three phase supply, then maybe even though you have 7.5 kilowatt onboard charger, normally in three phase supplies in houses, I think the people who have very big house like villa type of thing, if they have three phase supply, maybe for them it is okay. Otherwise, normally 7.5 kilowatt onboard charger is in normal single phase houses, that's not possible. It means it will operate, obviously operate at 3.7 kilowatt only. In US and Europe, it is 6.6 kilowatt onboard charger that is there, but in India we have 3.7 and 7.5, but 3.7 is mostly running onboard charger. These are some of the onboard chargers, 3.7 and 7.2, different in cars. Okay. Now, the important thing is cost decomposition in electric vehicles. If you take overall cost of an electric vehicle, your battery cost is 60%. Your battery cost is 60. The sad thing is, you have to replace that one only after few years. After 7 or 8 years, maybe now people are telling 8 years, I don't know 8 or 10, but you have to replace the battery only. The rest of the parts are okay. But that is contributing around 60% of the total cost of an electric vehicle. Motor is 15%, power electronics is only 20%, the others everything is 5%. So by this maybe we should understand how to increase the life of a battery. Yes, if you increase the life of a battery, then the cost you can save it a lot. Yes, okay. So for that your battery management system is required. Okay. Normally, previously lead acid, now lithium ion is it has good energy density, so people are going for this lithium ion. Is most commonly used due to its high power and energy density, and the battery has high energy density and low power. What do you mean by energy density and what do you mean by power density? Energy means stored energy, stored power as energy. Power means power density means maybe if I can give 5 kilowatt power at a time, okay, it means like at a time power, at a time how much I can give is power density, and how long if you add to that, that is how long if you add to that, that is energy, the time you have to multiply. How long means it is time. Okay, normally it means low power density means at a time battery can give low power, but it will give for high energy density means it will give for longer time. Yes, the battery has higher energy density, it means it can store very high energy, but it can give for at a time it can give very low power, it can give low power, because if you are drawing very high power, suppose you have battery and if you are your motor something, if you have overloaded, like if you see, even sometimes I feel like that only. Our autos, we are carrying the design for 3, we are 8 people are going in that. Yes, if you do the same thing with our electric vehicle, something autos, then what will happen? Sometimes the it you have to restrict that. Yes, restrict that. Maybe they will keep some program. I think they may keep some program to reduce the current rating. How much? Only this much it has to take. Even if you need high, you are giving acceleration, the throttle you make it open, but still you have to restrict the current. It means it will not go. Maybe they have to do some program, that type of programming. Otherwise, it will be your battery will be drained in means in 1 year you have to replace your battery. Yes, that's normally the problem. The battery, I think by this maybe we can understand battery high at a time. If you need very high power, it will not be able to give. Even if it gives, its life will be reduced. Okay, its life will be reduced. But I think in previously I have shown some of the things like here I have shown the acceleration is 0 to 60 kmph in 5.7 seconds. Everybody is mentioning that. It means it can pick up 60 kmph within this short duration, 5.7 seconds. It means to reach to that, it needs some energy. Where it will get? Like, I think if you have, for doing this, you have to increase the battery size. At a time, suppose I need 10 kilowatt. 10 kilowatt at a time, but only in the starting. Later, even 5 kilowatt is also sufficient to me for running in fourth gear or fifth gear. If I am running, maybe 5 kilowatt power is sufficient. In the starting, to pick up to meet this requirement, I need 10 kilowatt of power. very short duration, 5.7 seconds I need it. 5.7 seconds I need it. Then if you do this frequent starting and stopping, if you are drawing from 5 kilowatt battery, if you are drawing 10 kilowatts suddenly on and off frequently, then your life will be reduced. Your life will be reduced. But on top of it, you cannot make your motor, your battery equal to 10 kilowatt. Just you need for very few seconds, you can't keep your battery very high. For that case, normally, so for that case, normally there is one more capacitor called supercapacitor. It has very low energy density and high power density. It means it can give power. Suppose if you need 10 kilowatt, it can give it for 10 seconds or 15 seconds, but the energy is very less. The energy is very less. It has low energy density and high power density. So if you combine these two, your battery and supercapacitor, I think maybe I am repeating, battery can give, it has good energy, but in the starting we need very high power, it will not be able to give. The supercapacitor is like a capacitor, it can give very high power, for very short duration it can give. So if you combine these two, battery and supercapacitor, maybe your performance will be improved, okay? Because your performance also matters. Sometimes different people have different ride, ride in different way. So this hybrid energy storage system with supercapacitor increases the battery life, and also you can reduce the battery, you can reduce the battery for some, what do you mean, some size, and you can invest in supercapacitor. Maybe that will improve the performance, and also supercapacitor will normally have good cycles. If you see the lithium ion battery versus supercapacitor, this energy density is 10 to 100 watt hour per kg, that is only 1 to 10 supercapacitor. It means the energy stored in the battery is good, but in supercapacitor very less. And power density, this is less than 1000 watt per kg, this is around 1 lakh watt per kg. It means it has good power, it can give whatever the power if you want in very peak type of thing, like what do you mean by impulse response or impulse type of power it can give. And also one more thing, handling regeneration in batteries in normal electric vehicle is not easy. How much time you will brake? In seconds. It is going at very fast. You have applied the brake, and in that smart duration, the speed is reducing. At that time, the power will be fed back to your battery. It means for short duration, very high power will be produced, that you have to charge your battery. That's also not, that's why people don't know how to use that. Even they can't handle that much peak power. So normally they leave it like that. They don't go for regenerative braking, but they will go for normal mechanical braking. So in this, by using this supercapacitor, you can go for this regenerative braking, so that the power that is coming at very high power for very short duration can be utilized by using this supercapacitor. And the cycles, if you see, the cycle life is here 1000, here I think 5 lakh cycle supercapacitor. It means the battery maybe battery life, if I assume 8 years, then maybe supercapacitor may last for 16 years also, something like this. And instead of adding very big battery bank, small supercapacitor and big battery bank, little bit battery bank, smaller battery bank, and the battery you have to replace after 8 years, but supercapacitor you need not replace because the cycle life is good. And charge discharge efficiency is also very good. This is 70 to 85%, 85 to 98%. Then charging time is 1 to 2 hours. This is 0.3 to 30 seconds. And cell voltage, it's okay, it doesn't matter. Oh, it's not cost. Cost per watt hour, it's 0.5 to $1. This is $20. This is 0.5 to 1. See the cost. Here the cost is around 20 times. This is $1, this is $20. I think if you remember, when PVs were installed, it used to be, I think I can remember in 4 to maybe 6 years, 7 years before, or 10 years before maybe. It was not a feasible solution, like whatever the PV cost you are putting, getting the power, and there is no match at all at that time. It used to be very, maybe less than, in 10 years time, we are now, it is matching because your PV production has, means it is mass production has started, these panels. Even India now we are starting producing it. Now the cost has gone down, and now the PV power is also comparable with normal power generation from other sources. So in the, we can assume in the same way, if the mass production starts, then it will be, the cost may come down. Even the batteries also, lithium-ion batteries used to be very costly before. Yes. Now this one is, now the cost is little bit reducing. In maybe 8 to 10 years, even your lithium-ion batteries cost may also further come down. This charging temperature here only 45 degrees, here 40 to 65 degrees, and discharge also. Means overall, if you see the supercapacitor, it's very good in terms of its number of cycles, it means life, and also it's the at a time power handling and everything is good, but the problem is 20 times costly. So it means I'm not telling battery, keep battery this much, and supercapacitor also vary the same equal rating. I'm telling if you keep battery of suppose 10 times, supercapacitor of 1, only 1, 10:1, or otherwise 20:1. If you use, maybe you can save some of the, you can increase the battery life even by 1 year or 2 years. Maybe that will, you can get back the power. You can get back the money back. You can get back the money. Yes, these are energy density and power density curves of different different energy storage elements. The first one is electrolytic capacitors. This is ultra capacitors. This is double layer capacitors. This is lithium-ion batteries. If you compare this, like previously it used to be lead acid. Now they came to lithium-ion. Now the power density has increased around. It is 10 here. This is logarithmic scale. This is 10. This is 100. It means around 10 times the power density has increased. Yes, in lead acid to lithium ion. But if you go to ultra capacitors, this has further down to, sorry, this is 100 to, it's around 2000, around 20 times power density has increased from lithium ion to ultra capacitors. In the same time, if you take the energy density from lithium to ultra capacitors, this was further downsized. It's from 100 to 10 times. It's not 10, maybe it's 2. It's 100 to 2. The energy density is around 50 times less. It's the proposed thing is like this is an electric motor, this is an inverter. Now the previously it used to be power used to be taken from the battery, but now add small supercapacitor that can increase the battery life that we are proposing. Maybe some of the companies they are started using this supercapacitors, and here also you have to use one of the DC-DC converter. In supercapacitor also you have to use one of the DC-DC converter. And afterwards, maybe you may have some, you have one common storage, maybe capacitor. Okay. Can we stop? Okay. కొంచెం ఆపమంటే ఆపుతాం. నువ్వు నాకాశ చూస్తున్నావు నాకు డౌట్ వచ్చింది. ఓకే తీసుకుంటున్నాను మళ్ళీ ఇలా చూస్తాను నాకు డౌట్ వచ్చింది. ఓకే. This is a common capacitor here. I think in 10-15 minutes it's going to over. I think. Don't worry. కానీ అయిపోయింది మరో 10 మినిట్సే ఉంది. 10 మినిట్స్ ఉంది. కంప్లీట్ చేసిరా తప్పదు. 5 నిమిషాల్లో 10 నిమిషాల్లో అయిపోతుంది. అయిపోయింది. Okay. In this there are two energy storage, battery and supercapacitor. The battery is a primary energy storage. The supercapacitor will come in picture when in the starting and also when you require regenerative braking. It means basically when you need high impulse power, very high power for short duration. This is actually buck boost converter here in the after battery, and supercapacitor again buck boost converter, but this is bidirectional. And maybe because battery has to be charged and also it has to be discharged, and supercapacitor also you are using power sometime, but afterwards it has to be again charged. Yes, it has to come back to again threshold level, the same level. So that's why you have to use the bidirectional both sides, because this is used for regenerative braking. This is common load, and if this suppose if this load is everywhere, we have to maintain the DC link voltage here. The DC link voltage will be means everywhere we tell maintaining the DC link voltage. It means maintaining the DC link voltage means when capacitor voltage will be maintained, when input charge is equal to output charge, then only the voltage will be maintained. Suppose if you are continuously charging, then the voltage will increase. If you are continuously discharging, the voltage will decrease. It means when you are maintaining the capacitor voltage means you are whatever the input volt means it is discharging that much. If it is charging, then the voltage will be maintained. So in this case, if you take a resistive load here, suppose this is a vehicle now, inverter plus motor. Now suddenly the motor is demanding very high power. At that time, this capacitor voltages will be suddenly come down because this immediate source is these two capacitors. So the charge will be taken away from these capacitors. Then the voltage will come down, and at that time these two converters will be used to again recharge these capacitors. Okay, that's it means indirectly maintaining the DC link voltage. The same thing here. Here you are maintaining the DC link voltage, and that will give you, if you keep a PI controller, it will give you how much current it requires, okay, to maintain the DC link voltage. Now the current again, who will tell this battery and supercapacitor that which current should be taken from battery and which current should be taken from supercapacitor? That will be done with the help of this low pass filter. The total current will be divided into two parts. The average current, which is steady state current, and also the peak current should be supplied from your supercapacitor, and the average current should be supplied from your battery. So your battery, as you are dividing into two parts, this is after low pass filter, that is average current that is supplied by battery, and from the total current, if you subtract the average current, the remaining is transient current. This is transient current. This is total current minus average current. If you do, this is transient current. The transient current will be should be supplied from a supercapacitor. This average current should be supplied from a battery. So this transient current, this is battery. Suppose by chance if battery is not able to supply, somehow something happened, then that error will be given to the supercapacitor. That supercapacitor will try to compensate this. So from here there will be one current PI controller, here current PI controller, then you will generate the two pulses, SB1 and SB2. These are some of the results. These are only simulation results, and this is the load. Suppose the load was changed suddenly, the load current was changed suddenly. At that time, if you take battery current like this much very steep change in current, now battery may deteriorate. Battery always need a very what do you mean, steady current, or otherwise what? Not transient current, average current, or otherwise we don't want to give very sudden change in currents. Okay, if you suddenly change the current, if you are trying to dig out more current from the battery suddenly, then its chemistry will change, and they may polarize and all these things. It may spoil. Even if you take our vehicles, electric vehicle, even it is recommended to, even if you do fast charging for a week or for 2 to 3 times, you have to do slow charging again in your home, because otherwise the battery chemistry may spoil. So like that, here you don't require any change. So this is from this there are two components. So the same current we are dividing into two components. This is battery current and this is supercapacitor current. The sudden change is supercapacitor, this one is battery. Okay, so still the voltage is maintaining. Okay, the advantages is reduce the capital cost and reduce life cycles, improve overall drive efficiency, improve vehicle access. Okay. Okay. No. తన డ్యూటీ తను చేస్తాడు కానీ Huh, sir? That actually that depends upon rider. That depends upon rider only. Actually, we have not done any test on. Actually, that depends upon drive cycle, which highway or something like that. Maybe I'm sure definitely it can be improved, but for this question, I exact figure I don't have, but it can be improved. That's what I feel.
So what has to supply the high-voltage state? Now it gets recharged.
Hmm?
After delivering the high-voltage state, the capacitor gets recharged.
Yes.
Now it has to be charged again.
Yes, it will be charged.
Something is coming from your battery, right?
Same thing coming from the battery.
So then, when you are drawing higher power from the battery, so the light will be going very fast.
No, supercapacitor, once discharging, you are doing. Once you are charging, that's not a priority job. You can charge it slowly. We are not charging as much as we are discharging, we need not charge at the same rate.
But
Obviously.
generally, if we take the capacitor operation, it takes less time to charge as compared to the battery.
Yes, but here it is purely, it's completely controlled thing. Here, whatever the reference current, huh? Yeah, everything we are controlling here. Even discharge we are controlling, charge we are controlling. Supercapacitor. Huh. Any query? Anything? No? వెళ్ళిపోతే బెస్ట్ అనిపిస్తుంది మీకు క్లాసులు మీరు అక్కడ కూడా వినట్లేదు ఇక్కడే ఇప్పుడు ఎక్కడో కాడ వింటున్నారు ఎక్స్ట్రా కాదు కదా ఓకే సార్ చూడండి there are applications are there. Some of the very premium cars లో వస్తుంది నార్మల్ అప్లికేషన్ వరకు రాలే వెరీ గుడ్ ఐ థింక్ మంచి ఎక్కువ కాస్ట్ రేసింగ్ కార్స్ పనికొస్తుంది అనుకుంటా ఇది రేసింగ్ రేసింగ్ కార్స్ కాస్ట్లీ ఆల్సో నో ప్రాబ్లం వేగం అయిపోయిందా 1 అవర్లో అయిపోయిందా 1.5 hours పట్టిందా 2 ఓహో 1 hour 20 minutes ఈ 1 hourలో అయిపోయిందేమో అనుకుంటున్నాను నేను నాకు తెలియదు అవునండి విజయనగరం అండి